Now let us set the derivative of the mean squared error with respect to bi equal to 0 in exercise 1.3. So let's calculate the partial derivative with respect to bi of the mean squared error as we have expressed it up here. In the first term, we see that sigma j squared divided by Cij goes outside of the sum. And when we differentiate with respect to bi, all of the other terms, they disappear because they are constant values compared to bi. So what we then have is 2 multiplied by bi. And the derivative of this term is fj squared multiplied by the outer function differentiated, which is 2 multiplied by the sum inside. And let us just use k to index this sum, since we are differentiating a specific bi at the moment. And then we multiply by the derivative of the inner function, which is just a multiplication by 1. Okay, we have this partial derivative, and we set this to 0. This will imply something for the value of bi. If we isolate bi and just kind of ignore this sum a little bit for a while, then what we see is that the 2's, they cancel out on both sides, and bi should then be equal to fj squared multiplied by 1 minus the sum of the b's, and then we divide by sigma j squared, and we multiply by Cij, right? There we go. So that was just a standard isolation. And after this, what do we do? Well, we have the bi. However, it's not a nice expression that we have because there's a sum over all of the b's here. So the specific bi is also contained in the sum. And we want to get rid of the sum. So one way to get rid of the sum is to calculate what that sum actually is. So let us just try to calculate it. We substitute the value of bk using the expression that we have here. So we will be taking the sum over fj squared divided by sigma j squared multiplied by, well, multiplied by 1 minus the sum over bk for k ranging from 0 to, well, we can't use k here because we will have, no, it's okay. So for k ranging from 0 to I minus j minus 1, right? And then this summation, it actually works its entire way into only influencing the c term. So CKJ for the sum going from 0 to I minus j minus 1. And let us introduce the dot notation, where we use a dot on the k here to denote the sum of the total claims over all of the accident years, and also multiply everything into the parenthesis. Then we have this here. And now we see that the sum over bk appears two places, and we can isolate the sum over bk by adding this term on both sides, and then by adding this term on both sides and then dividing by whatever is necessary to isolate the sum. And we should arrive at the fact that this sum is equal to fj squared multiplied by the aggregated total claim sizes over accident years divided by sigma j squared plus fj squared c aggregated over the accident years. Okay, so now we have an expression for the sum, which we may plug back into the expression for bi. And since we are taking, we are taking this fraction and subtracting it from 1, that corresponds to subtracting the numerator from the denominator up here in the numerator. So what we are left with is sigma j squared divided by sigma j squared plus fj squared c dot j. These two cancel, and then we have c I j. So therefore, bi tilde given by fj squared divided by sigma j squared multiplied by cij divided by sigma j squared plus fj squared multiplied by the aggregate of total claims for the development year j. Well, we have that this value here for bi tilde minimizes the mean square error that was introduced in the exercise. We now would like to write up this expression as an estimator for fj, so we'll call that estimator f tilde. So, and f tilde j is equal to the sum over all available accident years of bi tilde multiplied by the development ratios. And we can plug in the definition of the development ratio inside the sum. And what we then see is that some things cancel out. So the development ratio is given by the next development year's total claims divided by the present development year's total claims. So these two cancel out, and the sum only affects this up here, which then aggregates to the total aggregated claims belonging to the J plus first development year. So we can write that as C dot J plus 1 divided by sigma J squared plus F J squared C dot J. In the exercise, we are also asked whether this estimator is useful at all, and our answer is no, it's not too useful. And the reason why we say it's not too useful is because in order to calculate this, you need the values fj, but those are the values that we want to estimate. So we don't have them readily at hand. Therefore, this method is really not that useful.